Good afternoon, everyone. I'm Peace Azugo. I'm a student of University of Pretoria, a master's student, and I'm under the Digital Forensic Science Research Group. And today I'm going to be talking about multimedia identity resolution in big data forensics. Okay, so we did a bibliometric study. Okay, and the outline of my presentation, I'm going to start with introduction, then I'll motivate why I did the study, and then I'll talk about my problem statements, the methodology, the findings, and the conclusion. Okay, so as we know, data has significantly grown in the computing networks due to so many reasons, like the increased use of smart devices, online services, cloud technologies, the internet, social media, Internet of Things, sensors, mobile technologies, and the high use of internet usage. But linking evidence in digital online cyber cases, cyberspace to a person's identity in the physical world is very challenging. So creating a need to understand complex technology and the identities of individuals. Did it go? Okay. Okay, so, but this data, the data we see today are multimodal in their structures, in that they are mostly images, text data, videos, audio. It has so many data types. And I was trying to say that trying to automatically ascertain the cyber identity of the user, it's challenging. Is it going? Accessibility and reliability and heterogeneity of multimodal data is also a challenge. Okay, so my problem was trying to identify works of literature that have been done in multimedia identity resolution forensics so I can identify the gap of multimedia identity resolution. Okay, and my motivation for this study was, according to that author, Apama Kumari, 2018, he examined and I discovered that unique nature and complexity of multimedia big data and noted that there is a need for efficient and effective algorithms to address the challenges like ensuring data security, privacy, system integration, and the integrity of network systems. The other author, Mary Catherine, 2020, also designed a systematic identity classification system, which was inspired by biology, cybernetics, and information theory features, and that featured a map to identity classes. But in that study, she noted that identity and attributes of users constantly change over time, and this can hinder cybercrime investigations. Also, this author, Olivia Binet and Rebecca Stewart, they asserted that entity resolution involves integrating information from multiple sources. And they noted that they discussed methods and approaches to accurate data linkage and emphasized that there is a need for methods and algorithms that maintain the individual level privacy of users. So I was trying to say that this study motivated my paper, my research. I was trying to understand how multimedia data forensics is being handled, because most of the studies were talking about image forensics, audio forensics, text data forensics. So my paper, I was trying to understand how to incorporate all these individual data types and then being able to identify users within that data types. Okay, so my findings from my bibliometric study and literature review, I realized that multimedia identity resolution in big forensics are not really done. They're not really studied. It's quite, not much is being done in that field. And then I also discovered that there's an essential need for multimedia big data forensics, as we can see on the other graph. Google Scholar is the only the only that databases. Not much is done on multimedia data, but quite has been done on big data. I also did a 2 keyword search on forensic chat, and I did on digital forensics, multimedia forensics, identity forensics, image forensics, audio forensics, video forensics, text forensics, all the multimedia data types. And I realized that on multimedia forensics particularly, not much has been done. So I think I missed a slide. I wanted to show you some of the keywords that we tried to research. Okay, so my methodology, I did a literature review. I tried to understand the meaning of identity, big data, multimedia data, digital forensics, identity resolution, and a review of related state of art. I also identified some keywords that I tried to search on my literature review, keywords like multimedia resolution, multimedia forensics, multimedia identity, identity forensic, big data digital investigation, big data forensic readiness, identity forensic investigation, image forensic, social media forensic, identity resolution, multimedia. So we researched a lot of keywords, and my research was within 10 years that passed from 2012 to 2022. And I searched these databases: ACM Digital Library, the IEE Explore, Google Scholar, Scopus, Springer Link, and also Web of Science as well. So we're trying to find out literature that has been done around multimedia forensics, and we came up with this chart to discover that not much has been done. So based on the study, although there exists some image forensic research studies, audio, text, video forensic studies, there are almost no credible peer-reviewed study for multimedia identity resolution forensics. Okay, and in conclusion, multimedia data are processed in cybercrime investigations. From our findings, we realized that for digital forensics, the data we use today for forensics is multimedia. It contains both images, video, audio, text data, all the data types for finding evidence of crime from this massive data. One main task of a digital forensic investigator is to compare identities. It's one of the major tasks of the digital forensic steps and procedures. They are faced to compare identities of users and ensure that conflicts of entities or individuals are correctly determined. So our future consideration is we're trying to integrate all the multimedia data types together so as to identify right features to extract for unique user identification from a multimedia attribute. And then we will try to create a model that uses AI algorithms like convolutional neural networks, probably for images and videos, and then the recurrent neural networks for text data to classify and then identify same users that have attributes of images, videos, audio, same users in all these data types. I think that's my last slide. Thank you.